I hope that's worked. It's being a little bit slow. Sorry, everybody. Okay, right. So I'm going to hand over now to Mary Colwell, who is the Director of Curlew Action.
Thanks. Hello, everybody. Again, and join Ellen in saying thank you for joining us. We're all at Curlew Action so overwhelmed at how many people are showing interest in these seminars. So thanks again for taking the time to join us. So anybody in the world of curlew conservation will have at some point over the last couple of years mentioned the word headstarting. It's become a sort of the vogue thing to talk about. It's because it's a really exciting technique. It's sort of tactile. It's got like a sugar rush associated with it because suddenly you've got lots of chicks in front of you, and it's really exciting. But I thought it's about time we talked about it in a bit more detail because it is a complicated thing. It's a nuanced thing. So we've got together perhaps the best people I can think of for sure to tell us about headstarting from a scientific, from a practical, from an on-the-ground point of view. And so first of all, I'm going to ask our guests if they'll introduce themselves, and then we'll come back and have a presentation one at a time. So I will start off by, Nigel, why don't you kick off?
So I'm Nigel, if you can see my name. I'm Conservation Breeding Manager at WWT, based at Slimbridge, and I'm going to talk today about how WWT got into headstarting birds. I'm not going to mention curlews. I'm just going to give you some of the background to some of the projects that we now have with headstarting as one of the sort of sugary things that we do.
Great, thanks, Nigel. Geoff?
Hi, I'm Geoff Hilton. I'm the head of conservation evidence at Wildfowl and Wetlands Trust. So I have a sort of broad-ranging scientific remit at our organisation, covering all sorts of things from social science to wildlife recovery. But I guess I'm in the fortunate position of being a complete curlew fanatic and getting to work on curlews. So I certainly will be talking about curlews quite a lot, and anyone who knows me will know that makes me very happy.
Thanks. And Amanda Perkins.
Thanks, Mary. Hi, I'm Amanda or Mandy Perkins, and from Curlew Country, and we are an initiative working on the Shropshire and Welsh borders, and we are completely immersed in curlews. And we started headstarting back in 2017. So we've got a bit of experience and development of what's been going on the ground. And I'm going to give you the context of why we started, what the background for that was in terms of our project, and bring you up to date with where we're up to.
Thank you, guys. It's, as you can see, you couldn't have better people actually to tell us about headstarting. We're really lucky that the three of them were available tonight and willing to talk to us. So thank you, everybody. Nigel, you kick off headstarting. Yeah. Just give us the background as to what it is and why WWT have become the world leaders in headstarting.
Okay, I'll try. Bear with me. I'm going to try and share my screen. This is how it's going to work, isn't it? I share my screen and the audience can see, yeah? Yeah?
Yep.
Is that going to be the right one? Okay, so I just have to go to get rid of all these notifications and go up a slide. Okay, you can see that?
Yep.
So that's Sir Peter Scott. So I'm Nigel Jarrett, Conservation Breeding Manager at WWT, and I intend to tell you about when and where and why WWT started to headstart waders. But first I thought I'd give you some definitions. So conservation breeding, what is conservation breeding? Well, for me, conservation breeding begins when individuals of a species are transferred from their natural environment to an artificial environment in order to produce as many viable individuals as possible to return to the wild to prevent extinction. And WWT has been using conservation breeding methods in species recovery projects since its beginning, when Sir Peter here developed conservation breeding methods for the world's rarest goose at the time, the Nene goose from Hawaii. In 1950, Nenes arrived at Slimbridge, and successful breeding occurred in the years that followed, and this led to several hundred birds being returned to the Hawaiian Islands, where birds were released on lava slopes on Maui, where they didn't actually do very well at first. But those released birds told us that nenes actually didn't live in these places that they'd been forced to eke out an existence in low numbers. They actually preferred to live on lowland wet grassland to find food and safety. So that reintroduction project told us a little bit more about neonate ecology that we didn't know, even though in itself it wasn't that successful. So even back then we learned that habitat recovery was critical to species recovery through reintroduction, or what we're going to talk about, which is headstarting. Oops. So now into defining a headstarting. So headstarting is a type of conservation breeding. It's an intervention that we use to increase the breeding success, in other words, the productivity of wild animals, wild birds in this case. So in the case of birds, headstarting involves collecting eggs from the wild and artificially incubating those eggs in incubators, then raising the chicks until they fledge, and then releasing them straight into the same population from which they were collected as eggs. Kind of cuts out the entire zoo collection aspect of conservation breeding. And we know that this taking into captivity from the egg to the fledged chick stage significantly increases the number of chicks that survive to fledge and reach independence, because hazards such as predators and pathogens and inclement weather or environmental conditions such as flooding or cold or wet weather are removed, and nutritional and healthcare requirements are met. Whoops, I keep touching this twice, sorry about that. So headstarting shorebirds to increase productivity of a wild population is a relatively new concept, but the technique has been used for the conservation of amphibians, reptiles and fish for probably about 50 years. I suppose the simple fact is that headstarting wildlife is probably as old as wildlife conservation and management itself. Gamekeepers collect eggs, pheasant eggs, hatch and raise them and release them. That's a type of headstarting. So headstarting, as I just said, is probably as old as the hills, and I guess helping individual animals survive, especially through vulnerable life stages, is an obvious and appealing way to improve the population size of a species and its persistence. So I can just move one slide at a time. So we could, I'm sorry, when I only put this talk together this afternoon, and my computer crashed and I lost the slide that this point was going to be made on, and I was going to say that WWT's been headstarting captive animals in its collections since 1946. Every year, thousands of eggs have been collected from ducks, geese and swans living in our zoo exhibits, hatched and raised in our duckeries, and then returned to captive bird exhibits. So we've learned how to hand raise and then return birds pretty much to a wild existence on an annual basis at our centres. And then with this species, we actually took this thing that we call headstarting into the field to increase the productivity of the species, which is the critically endangered spoonbill sandpiper, and we started that in 2012. I'm trying to get, the slide hasn't changed, has it? There you go. So spoonbill sandpipers, or spoonies, as we call them, are long-distance migrant shorebirds that live on the East Asian Australasian flyway. That's the dotted, enclosed in that dotted line area. So the birds breed in the sort of top right of the screen, where you've got that big blob, in Chukotka and Kamchatka, and that's in the Russian Far East, and then they migrate through Russia southwestwards towards China, southern China, Bangladesh, Myanmar and Thailand, about 6,000 to 8,000 kilometers from their breeding grounds. And the species, unfortunately, this species declined from around 2,000 to 2,800 pairs, that was the best estimate in the 70s, to 1,000 pairs in the year 2000. And then between 2000 and 2009, the population was declining at about 26% per year, with only about 250 pairs in 2008, when it actually became, it was classified as being critically endangered. In 2010, we really thought the spoonbill sandpiper was facing imminent extinction, and that extinction was predicted to occur between 2015 and 2020. So the species' long-term decline is likely to be the result of habitat loss and degradation, particularly the reclamation of intertidal staging areas around the Yellow Sea. But we also know that birds are trapped on the wintering grounds, and this appears to be a key reason for the sort of accelerated decline through the early 2000s, to get from 1,000 pairs to perhaps around about 250. So I'm just trying to remember what the point of this slide is. This is really just to remind me to say that studies on the breeding grounds indicate that the declines in the 2000s were driven by high mortality of young birds. So the proportion of fledged birds that returned to the breeding grounds was very low year on year. It seemed that just 0.05 birds were being recruited per adult per year. So that's like, 5 chicks returning to the breed from maybe 50 pairs breeding. In contrast, adult survival is about 76%, and the productivity of those breeding pairs is reasonable at 0.6 young per pair. That's 0.6 chicks fledged per pair, which is within the bounds of what we'd expect for a small Arctic breeder species. Unfortunately for the species, there is some evidence that most young birds, yearlings that is, stay on the non-breeding grounds for their first 2 years and are therefore more likely to be vulnerable to trapping, which explains why we're not getting birds coming back to breed at Chukotka. So in 2010, knowing that the bird was likely to become extinct in the next 5-10 years, we started a conservation breeding effort the following year, 2011. The plan was to establish a self-sustaining arc population and a specially built facility at WWT Snumbridge. And this thing is not far from where I'm sat now. In that year, May 2011, we flew to a known breeding site in northeast Russia near a village called Minor Pilgana with, I think it was about 1.5 tons of equipment. And we established a facility where we could hatch and raise eggs. So obviously, the first thing we do is go and look for eggs. Don't know if you could see that. We haven't actually got there yet. That's Minor Pilgana and the stuff that we took. Can anyone spot the nest? There it is. 3 eggs. So finding nests to any headstarting project, finding the nest, obviously, of a rare bird before predators do is probably one of the major challenges. It's probably one of the hardest things to achieve. Anyway, we managed to collect 20 eggs, and we managed to hatch 18 chicks from those 20 eggs, all on a boat in transit from Minor Pilgana to Anadyr, where the chicks were raised on the tundra there on an army base prior to being taken to Moscow Zoo. So whilst I'm doing this, to establish a conservation breeding project, I'm seeing all of the hardships that we were going to have to go through to get the birds, not just to Slimbridge, but then back again if we were to ever reduce them. But the fact that we could hatch 18 of 19 viable eggs on the move and then raise 17 of these to fledge in an aviary on the tundra in this airport town, this army air base town in Anadyr, it just shouted out to me that these were tough little critters that should be hand raised in situ and released rather than brought back to the UK. Why go to the trouble of establishing an arc when maybe you can actually bolster productivity there and then? So this led us to petition, if you like, for headstarting spoonies on location in Minor Pilgana, where the last known breeding colony was. I'll say it again, we knew it was going to be a faster, cheaper and less logistically challenging way to achieve what a traditional captive breeding project might actually not achieve, especially because it's based on the other side of the world, literally 12 hours flight away from where we are now at Slimbridge. This seemed to, obvious given that in the wild, spoonies, spoonbill sandpipers fledge, on average 0.6 chicks per pair per year, but we could fledge 3.1 chicks per pair from the clutches that we collected. So by headstarting spoonie chicks, we could provide a boost to what was a small population and buy some time for conservation measures to take effect. Because we ended up coming back, so we hatched the eggs on a boat and we started to raise them on a boat, and we were struggling to find natural food for the birds. The wind got up, so there were no mosquitoes around. We managed to get them to Anadyr without any loss and raised them on this air base, or this army base rather, with derelict buildings and tanks and dead dogs and gas masks everywhere. We managed to raise these birds to the point of fledge, and when they fledged, we flew them to Moscow, where they were held in Moscow Zoo's quarantine station until we could get the paperwork to bring them to UK. Now, unfortunately, there was a case of psittacosis in Moscow, in the sort of provincial area that is Moscow state, and there was a moratorium on moving birds out of the zoo. So our spoonies were trapped in the Moscow Zoo quarantine station, which was less than ideal conditions for shorebirds to live in, from August till November, when eventually they made it back to the UK, by which time we only had 13, and of those 13, only 4 were females. So the following year, we went back and we actually flew eggs back to the UK. We bypassed the rearing in situ and brought the eggs to the Slimbridge quarantine station, where we managed to hatch and raise another 17 babies. Now these eggs spend a full day either in the air, flying here, or in an airport, in airports lounges, waiting to get on flights. I'm telling you all this because I just wanted to understand the sort of like the realization that this was, you know, we couldn't. It seemed like we couldn't really kill the eggs or the chicks. They withstood a lot of ups and downs, quite literally, and we managed to hatch them. But I'm thinking this is great coming this way, but getting them back as eggs to Chukotka to release was going to be perhaps, you know, logistically next to impossible, because obviously if we ever returned the birds to be released, we would want them to be raised in situ so they can see the stars or the sun on the tundra, where they're going to be raised and hopefully returned to. So this is why I'm just labouring the point. It just seemed like a no-brainer to head start the babies in situ rather than to keep bringing them back into this captive situation. Now, that's not to say a captive population hasn't got a use in future, but head starting just gets you what you want quicker, especially if you're sorting out some of the reasons for the bird's decline. So in 2012, we trialled head starting. We piloted it with 9 spoonies raised and 5 redneck stints raised and released and migrated. They migrated successfully from the shores of this lake in what is a Chinese imported polytunnel structure covered with nets, with various kind of off-the-shelf animal houses that we bought from the UK. So we collected the eggs early doors in incubation to give females a chance to relay. So I'm sure you probably know that if you take, you know, normally waders lay about between 3 or 4 eggs normally, and if you collect the eggs in early stage incubation, before, you know, the females lost or males lost a lot of resource in incubating those eggs, they will relay again. So we set about, you know, attempting to double annual productivity this way as well, you know, by inducing second clutches that mum and dad could rear or have an attempt at rearing it. So in order to raise the chicks, they were hatched in incubators and then kept indoors. The town in Chukotka, I'm saying this really just to make everybody realize that you need facilities to head start animals in, and those facilities have to be as clean as possible. Obviously, you don't want any pathogens brought in by humans, and because you literally have all your eggs and all your chicks in one space, it's very easy to have cross-contamination. So we rented a small porta cabin type building house, and that's where the chicks were raised for the first 7 days of their life prior to being transferred by this Russian tank kind of thing called a Vesterhod to the release site, which I've mentioned before was a Chinese bought from China polytunnel that was covered with net rather than plastic. And then the birds were raised from day 7 to about day 30 in an ever increasing bubble of space, and slowly allowed to become more independent of the natural thing, of the artificial things that we provide, such as brooding temperatures. So we've in this what looks like a pheasant or chicken coop, we've got a heat lamp that keeps the birds warm at night. At around 17 days, the coops are removed and the birds are just given these rain shelters to keep the worst of the weather off them, knowing, you know, that rain is one of the major killers. Heavy rain can kill your fledglings. And then, as I said earlier, just now, or rather, they're released at about day 30. And they will usually hang around the release enclosure for 3 to 11 days, and then join flocks of stint and other spoonies heading south. So since 2012, when the project began, we've released 205 spoonbill sandpipers, and those have all come from between 8 and 10 nests. So we collect up to 30, to 40 eggs are collected every year from Minor Pilgner, and then hatched, raised and released. And we've had over 300 sightings from 8 countries on the Fireway, and we've had birds return to breed each year since 2013, including some of the babies that were released. So we've got some grandchildren out there from head started birds. And what we know from some preliminary analyses is that head starting is slowing the global decline by 3% per annum. So spoonies are not out of trouble. Head starting isn't saving them, it's just slowing their their rate of decline. We still have to solve the thing. We still have to implement conservation measures on the staging and wintering areas in order to keep this species going. Now, that was me trying to give a bit of background as to where Headstarting came from. I'll try and say it very quickly. WWT has been Headstarting its captive birds since the beginning. We were about conservation. We wanted to stop this bird becoming extinct. We established an arced population, and in doing that, realised that we could actually be much more successful than mum and dad at rearing the babies in situ, where the bird naturally occurs. And that led us to start releasing birds there once we knew some of the things that were killing them on the migration areas, in the migration and wintering areas, were being lessened. You know, reclamation is slowing down to stopping in some places, and some of the places that are netted, where birds were caught in nets, local people aren't doing that anymore. They're being encouraged to and helped to have other livelihood outlets. So that's me done, but I'm obviously going to be talking about, or could answer questions later about any technical or equipment related facilities related questions that people might have. So I believe I'm going to hand to Geoff now, who's going to tell you what I think you probably want to hear about most, which is curlew headstarting.
Thank you, Nigel. That was really interesting, and I think it highlighted just how involved this process is, how technical, how much organisation you have to do, how, you know, what field skills you have to have. You know, it's something that's a very involved process, and I think that came across really well. And for anybody who hasn't seen the spoonbill sandpipers, they're just such a treat. They're probably, she says, feeling a little bit treacherous, one of the most wonderful birds in the world there. So hand over to Geoff now, who's going to tell us about how WWT have really pioneered, along with Amanda, the using headstarting for curlews. So we know what it is now, but how does it fit in with curlew conservation? Over to you, Geoff.
Thanks, Mary, and thanks, Nige. So I'm just going to try and start up my. What are you seeing now? Oh, hang on. Gets me every time.
You need a presenter view, that's all.
Yeah, just trying to move my mouse around to the right bit of the screen. Here we go. Right, that better. Yeah, I should. Yeah, thanks, Nige, and I guess Nige was relatively modest about his achievements, but Nige is not only the sort of one of the best conservation breeding experts and aviculturists at actually looking after birds that I think the world has ever seen, but actually the idea of headstarting waders was his baby, and so I think a lot of what's stemmed from it in the UK is we should always remember that it was Nige coming back from Russia going, I think I've got an easier way of doing this. So Nige has explained a little bit about kind of where the idea came from, really, and one of the benefits of working on spoonies was, in a sense, we were able to take very high risk approaches because spoonies were doomed, we thought. It turns out we were a bit wrong, and things have picked up, partly from conservation action, partly because it turns out there are a few more birds left than we thought. But it was a case of, you know, don't worry if it goes wrong with spoonies, because we're stuffed anyway. And it allowed us a little bit of latitude to try something that was a bit left field, and so that's where headstarting kicked off. I'm now going to get into curlew headstarting. As I said at the start, I'm the kind of chief boffin, so I know very little about how to look after birds, but I've done some of the background thinking about, you know, how this should work, when should it work, why should it work, and that's what I'm going to talk about. So I guess I'll start with your today's population biology lesson, chaps. This is population biology in a nutshell. Births minus deaths is the change in population, and don't let population biologists tell you it's any more complicated than that. Now, curlews have a life cycle that looks a bit like this. Okay, so they start on the left hand side, they start as eggs, almost always, but not always, a 4-egg clutch, which hatch about a month later to become a chick, which fledges about 5 weeks later to become a fledgling. And then the fiddly bit is this kind of juvenile immature stage, right? So in the first year, they are, you know, as a free-flying bird, post-fledging, they are a bit inexperienced. There's quite a high mortality rate at that point because they're learning how to be a wild bird flying around. And then at 1 year old, they sort of, by that stage, they've cracked it. They've been through a whole winter and a spring, and their survival tends to be pretty good thereafter. They don't normally breed until they're 2 full years old. So they're kind of their 3rd calendar year, their 3rd spring, sometimes even later than that. And we're a bit hazy about exactly, but not until they become this 2-year-old plus adult do they start to produce their own eggs. So if we want our curlew population to be stable, we need to have enough birds reaching that adult phase as there are adults that die each year. That's the kind of curlew translation of that top line there. We need to have as many recruits joining the adult population as there are birds shuffling off the mortal coil at the other end of the adult population. And we know that for curlews in the UK, this isn't happening at the moment. The population is declining, deaths are exceeding births. Why is that happening? Well, we also know that it's not because an increasingly high number of the adults are dying, or an increasingly high proportion of the adults are dying, right? They're a very long-lived bird, and survival is high and has remained high while the population has been declining of adults. What's dropped is the productivity bit, by which I mean the eggs and the chicks getting as far as fledgling. Once they're fledged, curlews are doing as well as they've ever done, but they're not getting to that fledgling stage. So the challenge for the conservationists boiled down to is we've got to make fewer of them die or more eggs being laid, and you can't persuade a curlew to make more eggs, so you have to make fewer of them die before they reach adulthood. So each adult needs to replace itself during its lifetime with another adult in order for the population to be stable. But the numbers for curlews, it makes it sound like that should be pretty easy for them, right? They lay 4 eggs per year. An adult will normally, once it's made it to adulthood, live for another 10 years. So they're going to lay tens of eggs. They only need a couple of them to survive to make that 2-year-old adulthood. And you kind of think, well, how difficult can that be? And the answer is pretty difficult. So even in a curlew population that is healthy and breaking even, nearly 90% of the eggs don't make fledglings. And I'm just going to sort of walk you through this. So I don't know why I chose 6 eggs, because I think because it would fit on the screen, but 6 clutches of curlews in the spring. This is in a healthy population, which is stable, okay, would typically lead to only 7 chicks. That's natural mortality, mostly predation. And those 7 chicks would typically lead to 3 fledglings. 6 clutches, that's 20, that would be about 22, 23 eggs, because a couple of them aren't 4-egg clutches, 3 fledglings. So nearly 90% of your potential curlews are gone by the time they reach that 5-week-old fledgling. After that, things get a whole lot better. So those 3 fledglings might make 1.5 immature, so about half of them, a bit more than half, will die before they make that kind of 1-year-old stage. And at that point, their survival is spectacularly good. And those 1.5 immatures, I'm sorry, I'm dealing in half a curlew, they will make about 1.4 adults. But you can see that the huge proportion of the losses of that sort of potential curlewness is in those early life stages. And what this means is that if we want to reduce the number of deaths, if we want to increase the number of birds reaching adulthood, the scope is there. The gap between what actually happens and what could theoretically happen is that in those early stages. And this, you saw Nige flash up those original papers about headstarting being invented for turtles. They're like a curlew in spades, because of course they lose 99% of their babies in those very early life stages. So again, take them out of harm's way for that little period, and in a curlew that is only 9 odd weeks of life, and you've got through 90% of the mortality phase. So that's why, I guess in a nutshell, that's one way of looking at why headstarting feels like it's intuitively a good idea. So just a sort of reminder, why do we lose so many so early, even in a fairly natural situation? Is because the eggs and the chicks aren't very good at getting out of the way of predators, unlike a free-flying bird. And there are a lot of curlew predators, as we know, and the number is high and increasing. And they can't get out of the way of other hazards like floods and mowing machines either. So basically they're very, very vulnerable in these early life stages, and after they get to once they can fly around, they are a relatively invulnerable animal. So just to kind of just go back over looking at the numbers game in a different way, why do we headstart waders? Well, in a typical British population, you've got this female, she turns up in the spring, she lays 4 eggs, and in a typical British population at the moment, broadly speaking, we're talking about her producing 0.3 fledglings per year. that is a population with that level of productivity will be declining, but most British populations are declining. We think break even is something like 0.5 fledglings per female per year. Don't quote me on that. That's roughly. Now, if we head start them, as Nigel kind of touched on this, we take those 4 eggs into captivity, and with the success rates that we learned that we could achieve through spoonbill sandpipers, we got to about 3.2 fledglings per female. So we have increased the productivity of that bird tenfold, thereabouts. That's why head starting kind of intuitively feels like, blimey, this might help. So what happened since then? Well, Mandy started it first, and with great innovation and a certain amount of bravery, because this was not a well-known technique in Britain. Curlew Country started head starting back in 2017 and have carried on ever since. A little bit after that, there was a little bit of a fortuitous, in a way, in an ironic way, discovery. The little black dots I've just put on the screen are airfields, and it turns out, and we genuinely didn't know this until a few years ago, that airfields are really good for curlews, and I think it's because it's a big area of relatively chemical-free grassland that is very undisturbed, because the RAF don't really like people wandering around their airfields, and so curlews have latched onto them. We didn't know this, but when we started to find out there were quite a lot of curlews, the other thing we found out was that the curlews on the airfields are quite often, their eggs are destroyed because adult curlews flying around protecting eggs are a danger to aircraft. A very serious danger. So there's a license, this is all legal, licenses given to destroy curlew eggs near airfields, which presented us with the opportunity to get hold of some no regrets eggs for head starting. And so, out of a pretty unpleasant and sad situation came a little bit of an opportunity for conservation. And that led to, in 2019, we tried a trial head starting operation in the Severn Vale, which is where we are based. So the red dot is WWT Slimbridge, and the sort of strange red thingy is kind of Severn Vale areas that we hoped would be the beneficiaries of the birds that we released from Slimbridge in 2019. Now, this was meant to happen in 2020, but it actually happened in 2021. 2 new head starting projects started, one in Dartmoor, on which, well, I'll come to the partners later, or I'll forget all their names, but one which we started in Dartmoor, and one which is led by some partners. We kind of give a bit of advice up in the east of England, in Norfolk. And those 3, Curlew Country uses eggs from Shropshire, but the other 3 projects take eggs from airfields. So head starting, then, I've kind of talked about why the numbers stack up to make this look like quite a nice conservation technique. The question is, does it work? And the first question about that is, so are you actually able to successfully rear and release curlews? The second one is probably, and when you have released them, do they do okay? So the answer to the first question is a pretty resounding yes. So in the Severn Vale in 2019, you can see the numbers there. 86% of the eggs ended up being a released fledgling, and in Dartmoor last year, pretty similar numbers. So we know that the sort of numbers that Nige talked about for spoonies are true for curlews. You can release the vast majority of the eggs as healthy fledglings, and thinking back to my original diagram, that's an order of magnitude better than the wild birds are going to achieve. So that side of it is we know that works. What about the sort of, I guess, the scarier question, and are these birds any good in the wild? And then you might think, well, they're going to be dafties. They're not reared by their own parents in a natural habitat. They won't know what to do, and so therefore, will they die young? Will they know how to behave like a curlew and be a wild curlew? And I guess the ultimate question, because this is the point of doing this, is will they come back and breed in the population you were trying to help? So those are the big questions, and we have some of the answers, but not all. I'm going to talk about Project Godwit a bit, which is the other way to head starting project going on in the UK at the moment. Started in 2018, I think we did our first cohort, and it's an attempt to head start black-tailed godwits in the fens of eastern England, and we've got some pretty good data on this. This has been funded by the EU, dearly departed, and it's a well-resourced project. We're able to do quite a lot of high-level monitoring. So question one, do big waders that have been head started in a UK project, do they survive okay? And the answer is yes. Our head-started godwits, don't worry about the details there, but basically the head-started godwits survive at pretty much the same annual percentage as a wild godwit. It's very, very close, possibly even a bit higher actually, but we're still working on that. So yes, we do release birds that are perfectly capable of surviving in the wild for multiple years. You know, we've got 3 or 4 year olds coming back now. Do they sort of know what to do, how to be a proper godwit, not a curlew? Well, we've been tracking some of them with geolocator devices. This is just an example of one bird's track down to West Africa and back. And so with a relatively small sample size, we now know that, yes, a head-started godwit makes the same sort of migration at the same sort of time all the way to West Africa of its own accord, just like a wild bird. So yeah, they do and we've got some behavioural stuff as well, but basically, yeah, they do seem to behave like a proper wader. So that's good. And what about the kind of, do they come back and do they breed? Again, for godwits, the answer is very much yes, and we pretty much know this now. So this graph shows the population of godwits on the ooze washes in the East of England fens, and the grey line is what Geoff's WYSI population model says would have happened if the project hadn't happened. So the kind of first few years are reality. They're what was happening, where there's about 3 pairs there. They're what was happening before we started. And then the grey line beyond that is what we think would have happened had we not done the project. And the orange line is what has happened to that population as we've done the project of 3 years of head starting, missing the COVID year. So most of the godwits on the ooze washes now are of head started origin. Their breeding success seems to be pretty reasonable, and the project as a whole has achieved the goal of making a rapid boost to a critically small population. So Project Godwit is saying head starting waders works. For curlews, we know much less. It's earlier days and they are harder things to monitor for a variety of reasons I don't have time to go into. But we do know one thing, and my colleague, my new wonderful colleague Joe Morton, who I think might be on this call actually, has been number crunching for us in the last couple of weeks. The 2019 birds that we released at Slimbridge in the Severn Vale, we've got quite good resightings of those, and we know that their survival through the first year was very close to the recently published values for wild curlews that the BTO published a year or so back, and that actually in the winter just finishing, about 40% of the birds we released were known to be alive at least some point in that winter. And that's again very much in line with the expectation of wild curlews in this region. So they're surviving as well. The rest of the bits, are they behaving normally while they're wintering on the estuary? Are they coming back to breed? That's a bit more of a question. So what do we know then? In summary, we know that head-started waders survive, migrate and breed similar to their wild counterparts. I've messed up this slide. Never mind, sorry about that. The question for curlews specifically is, oh no, I haven't messed it up. Head-started waders survive, migrate and breed. Head-started curlews survive, but the return and breed bit for curlews specifically is the bit we don't know. So what don't we know? Do they return to the local area and breed? We know that wild curlews do tend to return to their natal area, to where they were reared, okay? Now, the figures on this are a bit sketchy, but I actually nabbed some figures from a very old scientific paper the other day and got these sorts of numbers. So, you know, about a third of them are literally, you know, within a few kilometres. More than half of them are within a sort of 10-mile radius. And then a smattering of them go further afield into the landscape. And some of them go genuinely, you know, all over the shop. So we know that the natural situation for curlews is that they do basically return home. That's what waders do. That's what curlews do. Just a sort of reminder, you know, if our curlews are alive, but they're recruiting into a breeding population a long way from the population we're trying to help, then it might give us a lovely warm feeling that, you know, we released this bird into the wild and now it's breeding somewhere. But it's probably not meeting our project's goal. It's not doing what we want it to do, which is boost the target population. This map is showing what ought to be happening if those sort of return rates that I've shown there on the side of the graph, on the side of the slide, are true for our head-started curlews. This is a map of the Severn Vale. The blue dot is Slimbridge again. The little white splodges are the curlew sites, the breeding sites for curlews in the Severn Vale, and I drew some sort of concentric circles around Slimbridge. So the bright red circle is 3 kilometres, and so given how many birds we think are still alive, we would expect about 6 of our head-started curlews to be recruiting as breeding adults into that very locality around Slimbridge. Then the sort of pinky one is that further afield 15-kilometre radius, and if they're going into the Severn Vale, we'd expect about another half a dozen birds in that area. And then the sort of salmony coloured one is that kind of 50-kilometre radius, and we'd expect a smattering more of birds in there. And at the moment, as of last year, we don't have anywhere near that number coming back. We can't account for them. We know they're alive because we're seeing them in winter on the estuary. Where they're going to breed, we don't know. Now, it may well be that they just simply, we missed them because we've had issues with sort of monitoring capacity. It may well be that some of them aren't going to come back till they're 3-year-olds, which is probably fairly regular with curlews. So, you know, it may be all fine, and I might give this talk in August and say, hey guys, they all came back. But at the moment, there is a question about the birds may be alive, but are they recruiting where we kind of thought they would into the population we were trying to help? So that's the big unknown, I guess, at the moment. And then I'm just going to talk a bit about the limits. What's wrong with head starting? Why, given the numbers I gave you earlier, 10-fold increase in productivity, why don't we just do this everywhere? And then a little bit about what it is good for. So the limits of head starting, very simply, it costs a lot of money. It's quite difficult. It's quite risky. You can't do that many. And it's a sticking plaster. And I'll come on to what I mean about that in a moment. So it's expensive, difficult and risky. This is Sparky, Mark Roberts, one of our AVICs, one of Nigel's team. He's actually only 25 years old. He looks older because he's knackered because he's been getting up all night looking after baby birds. It's hard work. We put a lot of people onto this. As Nigel sort of said, we tend to have purpose-built facilities. We worry about biosecurity. You need incubators. Now, it doesn't all have to be done super posh, super high end, and we always try to do it that way. But nonetheless, you have to know quite a lot about rearing birds, and you have to spend a fair amount of money or on staffing, etc., and equipment. And the risky bit, the reason I say that is because you've got all your eggs and all your chicks in one place. If, for instance, a fox gets into your rearing pen, you've lost the lot. You haven't just lost, one brood, as might happen in the wild. You've lost the lot in a wanna or a disease. So the risk is, if it all goes wrong, it all goes wrong. The numbers are limited thing. So a head starting operation with a few avicultural staff and a big polytunnel, you can rear a few tens of birds. As we get better and smoother at it, you might even go up towards 100 at a push. But nationally, we need thousands more curlews to fledge to hit break even. Okay, this is what Graham Appleton, one of the gurus of wading conservation in Britain, said recently. That's number crunching of the shortfall of wader fledglings, of curlew fledglings that we've got in this country. That would need a ridiculously large head starting operation. So with head starting, you can make a massive difference to that population's productivity if your population is very small. 5 or 10 pairs, you're making a huge difference. 40 or 50 pairs, you're making a big difference. If you've got hundreds of pairs, you're starting to get drop in the ocean. And if we look at sort of upland northern England, there are still thousands of pairs. And so you're just not going to make that much difference to the overall trend by putting in these, 30, 40, 50, maybe 100 birds. It's just a numbers game. And the final thing is this sticking plaster idea. So, I guess the goal of conservation really is to create an environment, a countryside in which the stuff that we like, in this case curlews, thrives. And we want the British countryside to be capable of supporting wild curlews. And if it can't, then I guess we should be quite worried about what we're doing to the countryside. But head starting isn't sort of fixing this underlying problem that at the moment our environment doesn't support healthy curlew populations. It props them up, but it doesn't solve the underlying problem. Now, I really want to stress that is true of head starting. It's also true of lots of other stuff people do to save curlews and other birds. So if you put up a nest fence for curlews, it's a great thing. It helps them. it is also a sticking plaster by the same line of argument, and actually so is predator control. You know, it's not really an intervention that anyone wants to do. The effect of it stops as soon as you stop doing the predator control. The nest fences stop working as soon as you stop deploying them. Head starting stops working as soon as you stop head starting. So it's that kind of well, you get the idea. It's kind of not really dealing with the underlying symptom, but I would stress plenty of other things don't deal with the underlying symptom either. So don't sort of demonize head starting for that reason. So after all that, what is it actually good for? You know, essentially what I guess Nigel and I might argue, and Mandy as well, I'm sure, is, you know, it's not the solution, but it's potentially part of our curlew toolkit. And specifically going back to that spoonbill sandpiper example is a really good example. It buys us some time. It can prop up a small population by, you know, 10, 20 plus years, because these are very long birds once they do get out there. So if you've got a small population that's going down, then head starting can give it enough of a boost to buy you a decade or two to solve those underlying problems. And some of our curlew populations are now so small that they do need that time buying for them. And if you've got a really small population that's doing just about okay, but it's only 3, 4, 5, 10 pairs, then a bit of head starting can kind of get it out of that bottleneck and start to get it just a bit more robust. So that's where I think curlew head starting fits into the curlew conservation jigsaw. But I think that the corollary of that really is that you can't see head starting in isolation. You know, it is part of a bigger fix. If you've got one of these small curlew populations, as we do have on our patch in the Severn Vale, head starting may be part of the thing, but you've got to have a plan for how are we going to fix these underlying problems in the wild. Now, that doesn't necessarily mean you've already fixed those problems, or even that you know exactly how you're going to fix those problems, but you've got to kind of be thinking ahead to look, what do I think might be needed? What's my light on the horizon? What do I need to research to find that light on the horizon? So I guess it's about integrating it into the rest of what you're kind of trying to do. But with that said, and also with the uncertainty about how well it actually is going to work because of this question about recruitment, you know, I think we found out with spoonbill sandpipers and with godwits that this can be a very powerful technique in the right circumstances, and it does seem to work pretty well. So yeah, I guess I'll end there and hand over to Mandy, who has been at the really sharp end of actually making this work in challenging conditions in the field. So yeah, thanks very much for listening to my bit.
Thank you, Geoff. That was absolutely fascinating, and I think it shows as well that there's just a lot more to it than just pumping birds out and it all's going to be okay. And I think you brought that over really well. Before we move on to Amanda, can I just do a quick announcement? Anybody who hasn't, could you please fill in our little survey right at the top of the chat? Or perhaps, guys, you could put one in a minute. It just gives us, it's only one question, and it gives us an idea who's joining this so that we get a feel for who's interested. And secondly, another link's going to go up because we'd absolutely love it if you would help support Curlew Action to keep putting on our outreach seminars, our information seminars, to sort of help spread the word about it. So thank you very much. So, Amanda, we have known each other for a while. You are such a conservation goddess. Nobody has, I don't think anybody has done as much on the ground, been through as much pain and kept the faith as Amanda has. I mean, you are an inspiration to all of us, actually. And you know more than anybody what it is like to be at the sharp end of making head starting work for a very beleaguered population of curlews. So we'll hand over to you to give us your experience, and get your hankies ready, guys, because I think it is quite a story which you need to write into a book one day, Amanda. Thanks.
Thank you for that amazing intro, Mary. And yes, we have. I remember you coming up when you did your fantastic walk, giving us support that we needed at a really crucial time. So it all works both ways. Thank you very much. I'm going to start screen sharing, I hope. So I'm going to go into screen sharing mode, and my presentation, I think, will be a bit shorter than the others, and it will be a bit different in style because we came at this, as Mary says, from a really different direction to everyone else. and I know that when I started to work with curlews, I had no background of, I'd always worked in conservation, but not like Nige and not like Geoff. I'm not a boffin. I'd always been a boring old manager, perhaps a bit of a problem solver. And I remember doing internet searches for curlew recovery projects, and only coming up with lapwings really for waders, which were the closest thing. And I remember thinking that I must be rather useless at my internet searching, but actually have realized later that we were at the very early stages. So we were unintentionally sort of trying to design a project. Can you see my screen? No. Ah, that's a problem. Any better? Great. So Curlew Country was one of 15 projects, I think, in a landscape partnership scheme, which is a heritage lottery funded setup, and we really grew out of that. And the project was designed along traditional lines. So my job was going to be to go and speak to farmers about what they were doing with their land management and how they should manage habitat better for curlews, and to try and get them into agri-environment schemes. That in itself was a bit of a challenge, because they were saying to me, well, look, we really love curlews, but you guys have got to get real about everything. Which really meant that they didn't see why they had to manage their habitat unless we addressed predation control as part of our package. So we redesigned our whole project to work in partnership with farmers to find out what was going on. And as we've said, we started Headstarting back in 2017, and we now released a total of 94 chicks over the years. We work with 40 plus breeding pairs in the Shropshire and Welsh borders, and our farmed lowland, although we're hilly country on the Shropshire and Welsh borders, we're considered to be lowland. We're not that real upland landscape. So our farmers said to us, look guys, we'll work with you, but we need you to keep an open mind about what's going on here with our curlew population. So we agreed that what we would do is we would set up cameras on nests and use some data loggers to find out why our curlews were failing to breed successfully. And we knew that they were failing to breed successfully because a local volunteer group had been doing adult breeding bird surveys over a number of years, and they'd witnessed the decline that Geoff and Nige have talked about, which was similar to the national decline in the population. And when we started working with that curlew population, we realized that they were probably experiencing senescence. And again, Geoff's talked about this, so something urgent needed to be done. We monitored we monitored a total of 30 nests, and from those nests, that was over 2 years, 2015 and 2016, no chicks survived to fledge in either of those years. In each year, only 3 nests got beyond egg stage, but the chicks were lost almost immediately. In the second of those years, we found out about Natalie Meyer at Nabu in Germany, who was trialling electric fencing. So we trialed that on our 3 remaining nests and knew that that helped. And our chicks got to a hatch stage. Sorry, I'm saying hatch instead of fledge. But our chicks were lost. And this was, when you're working with that, it's really devastating. When you're finding another nest that's destroyed, when you're finding or having news that another nest is destroyed, I can tell you, even our very experienced ornithologist was getting pretty down in the dumps about what was going on. 75% of nests failed due to predation at egg stage, mammalian predation. but we knew from our anecdotal evidence, because we had then started, as you know, putting up fences, that if we hadn't found those nests and notified people as to where they actually were, they would have been destroyed by accidental agricultural activity. And it is accidental. The farmers were so relieved when we were finding nests in their fields and knowing that those birds were protected. But as we found out, and others have found out, farming and breeding curlews don't mix terribly well. And you can see in this slide, there's a badger selfie caught on the camera, a camera with a nest, but very importantly, that's a dairy farm over on the right-hand side. And you can see sort of in the centre, toward the left, there's a little patch left there with a nest left in it. And the challenge for those birds when they actually hatch, with chicks coming out and into that heavily mown area around, and predators looking at that grassland and thinking, oh, what's in there? We'll go and investigate, which is their natural instinct. These birds are facing so many challenges. Having said that, we knew what was happening at nest stage, and we needed to find out what was happening to the chicks. So the following year, and I'm smiling as I say this because as someone who's not a technical boffin or a scientist, I had said I think probably the year before, really, we need to save these birds from dying out. We need to save our local population. So should we be taking the eggs and rearing them? I had no idea what that actually meant. So in the way that Geoff and Nige have described. And we have a little technical group because I'm not an expert, and everyone looked at me as if I was crazy. But we did apply for a license to Head Start, but at that stage it was to return eggs to the nest at pipping stage, because we knew what was happening to the eggs and we wanted to find out what was happening to the chicks. We were left with sorry, I'm running on ahead of my slides here. So pipping stage, for anyone who doesn't know, is when they're just about to hatch, when you're just getting signs of hatching on the chicks. So we were left, and the birds don't know. So there's a bit of trying to manage the nest in the best way. The curlews are laying eggs. We're taking, because those eggs are predated so quickly, we're taking them out very quickly and putting dummy eggs into the nest so that they can continue laying until they've got a full clutch, and then we return pipping eggs to the nest. And the birds didn't know, because the birds are nesting sequentially, they didn't actually know that they hadn't been incubating for the required period. Their instincts to deal with the chicks kicked in pretty quickly. But very sadly, the nests, all the chicks were predated pretty quickly, and we didn't have any active nests, and we were left with 6 chicks, and we weren't expecting to have to rear chicks. And the photo that you see in the top left here is those chicks being reared in a very basic pen at that stage, because we weren't prepared for this. The picture that you can see, you've got one dummy egg in there. Spot the dummy egg, and the picture in the bottom left-hand corner is actually of a curlew, that a juvenile curlew that we managed to rear that year. Now we reared, sorry, not reared that year. We trialed predation control in that year, and we trialed working with farmers to reward them for crop sacrifice. So we got some chicks away from that, and then we had these 6 chicks that we reared, and we released them at a migratory roost spot, because we wanted them to have a chance to be with other curlews. But we then knew that we could do that, and everything else was failing, and what have we got to lose? So the following year we applied for a license to Head Start fully. I've spoken about us as sort of being slightly unprepared for the first chicks that that came our way, but we did manage to do that. We were equally unprepared, I think, in 2018. I'm a farmer's daughter, so I'm used to rearing animals. I kept chickens, but we didn't have a book telling us what to do. No one in the UK had head-started curlews at that stage. Geoff and Nigel and their teams were really encouraging and really helpful at a distance. But basically, we were the project officer, Amber, and I were two inexperienced, unskilled members of staff incubating eggs and rearing them. And we had a license to take up to 50 eggs, and we took 50 eggs and we released 21 chicks that year. Our equipment was rudimentary. Our pen was rudimentary, but we did it, and it was a golden year. And for us, the really crucial thing was that we couldn't do any worse than no chicks in the wild. So whilst Nigel and Geoff are so professional that they haven't talked about the stress of the responsibility for every single egg. Every egg is so precious, and you're doing every egg and chick are just incredibly precious, and you're doing everything that you can to help them. So we did experience that immense pressure, but it was a huge privilege, and it's a huge privilege when the chicks are teaching you as well. So we had them in an enclosure, but we had them in a smaller enclosure, and really they told us when they didn't want to go into the smaller enclosure. So we learned a lot in that year. In 2019, WWT came and became a partner for us, providing much needed resources for the head starting work. And they famously dubbed it a one-year stand, but it was a brilliant one-year stand. No regrets, guys. You were fantastic. Thank you. And the really crucial thing, their expertise is brilliant, and we learned a lot from them. But the really crucial thing we found was the upgrade in the equipment, which meant a big difference in the egg to hatch rate. So it improved that considerably. And 33 chicks were released that year. In 2020, we didn't operate because we had COVID. So just to go back, you can see that's a little hen incubator with the chick peeking out at the top. And you can see in the picture on the left, one of the WWT team with much better equipment, like the sort of equipment that you've been seeing in Nige and Geoff's slides. In 2021, 2020 was COVID, and we didn't operate. Our farmers didn't want us to operate. So this last year, we released 34 chicks. We had one main member of staff, the project officer, working with a team of volunteers. Now, as Geoff has said, a certain amount of expertise is needed, and it's not something really. It could have all gone so wrong in the ways that he has described back in 2018. So you do need to know what you're doing. You do need really good kit, and that is expensive. But our rationale for doing this was that in 2017, after doing our trials of lethal predation control, which we knew was needed, and our rewards to farmers for crop sacrifice, we realised that the cost of those interventions was so great and very likely to be needing to be linked to AES that we just couldn't do that. So we went down the road of head starting, but we still are not an initiative that's flush with cash, and we have a fantastic volunteer team, one of whom you can see here. And the picture of the two people on the right hand side of the screen, that we have trainee volunteers as well, and we're so fortunate to have that. So as long as you've got skills at the forefront, we have managed to work with volunteers in the background, lending absolutely vital support to us. Geoff talked about why headstarting, and our 3 key findings are here: some birds better than no birds. But another reason is that when we started our project and we engaged people widely, and we found that people love curlews and that they wanted to be involved with them, as you all are, those first 2 years were so devastating, with the news coming in of nest failure after nest failure. So as well as wanting to save our local population from extinction, we quickly found that actually telling people some good news and giving them ways in which they could get engaged more positively with our work was a big bonus as well. Curlews, as many of you will know, are really difficult birds. Nigel's talked about the difficulty of finding nests, and Mary often talks about Bicheno and his role in making curlew nests difficult to find and making these birds very, very difficult to measure to observe and measure their behaviour. So actually, this is a way for people to get much more involved with sort of hands-on work and doing something positive while we're trying to find those better solutions for the longer term. So just to reiterate, we have learnt a lot, and we've certainly learnt a lot from WWT, to whom we're very grateful. I think, I mean, perhaps we were mad, perhaps we were brave, but we got nothing to lose. We had no chicks, so we had nothing to lose. But I absolutely agree with what Geoff has said. This is not a solution. This is a temporary measure, and we must work really hard on getting to that longer term place, which many of us have come together in the Curlew Recovery Partnership, and Mary and Curlew through Curlew Action is trying to achieve. But it is something that can be considered to save birds and to stop them from becoming extinct in the meantime. And whilst, as Geoff has said, it is expensive, actually the natural alternative is a great deal more expensive at the moment. And that's it from me, Mary. Thank you.
Thank you, Mandy, for that insight into the real sort of emotional side of doing this technique, which we talk about, sort of a scientific technique, conservation technique called headstarting, but there is a real human side to it as well. And all that emotion of desperately trying to find the solution to a disappearing population that's going from under your eyes, you know, birds you love very much, and trying to get the science to work for you. And it's really not that easy. So I'm going to now ask Ellen if she will read out some of the questions that have been coming in. Do you want to kick off, Ellen?
Yeah, sure. So we've got a lot of really good questions. So we might not have time to do them all, but actually the first one is one that I wanted to ask as well, and it's actually from Mary, and it's for Nige. What were the main problems that your chicks were having to overcome? Was it disease or cold, or what was it?
So Mary, you're asking a question to me about
about your spoonies. What were the big issues that you found doing that first headstarting project?
Well, because it's a far-flung place, Chukotka, it's getting the consumables there, so it's more logistics. We needed food, so I think one of the things I said, you know, what you guarantee in headstarting, when you bring an animal into captivity, you can keep predation away, you can keep pathogens at bay. You've got to feed your animals appropriately. They've got nothing but what you provide them with. So every year we have to, you know, ensure that the heat lamps that we provide is brooded to give the birds appropriate temperatures to live in, or get there in an intact way. And food has to be literally mule there. You know, the staff who leave from Slimbridge every May time have to carry everything that's needed, and that can just be awkward because no 2 years are the same with respect to import and export rules, it seems, and obviously we're not going to do it this year because of what's happening in Russia right now. The bird we lost a few eggs, but we don't know why they didn't hatch. It could be that there was something happened when we transported the eggs. So we collect eggs in an area that is surveyed, and it's probably maybe 15 to 20 kilometers in diameter, the area around the base, and the eggs are carried in portable incubators, battery operated, 12-volt battery operated incubators on the back of a trike. And it's possible that moving the eggs and shaking them around causes malpositions. So but we've lost very few eggs, and not all the eggs die of the same thing, despite being transported the same way. So whether there's just some kind of those eggs were destined not to hatch, we'll never know. We also just have to. I think we're called experts because we've made a lot of mistakes in our time. We've just as an expert, I've just made a lot more mistakes than most other people. So we stop things going wrong by making sure that we keep temperatures appropriate to the incubation stage or the chick rearing stage. We feed appropriately. We watch how the birds grow. So because we're dealing with the greater number all the time, it's a numbers game. So if we do have any birds that are not behaving properly, we've got to be very careful that we don't waste time investing in the birds that maybe weren't cut out to survive. That's not to say we neglect them, but animal welfare is always the thing that is that's what we base all of our methods on, good welfare standards. But we accept that not all animals will live. So out of 20 chicks, you probably are going to have a couple of losses, and sometimes when you investigate, you perform a post-mortem examination, you can't find anything that tells you what the bird died of. But we're obviously very concerned all the time, as Geoff mentioned, about disease getting in, because the animals are raised in the same place. Any problem, like any ingress of disease could be devastating, could kill everything. So and that's one of the bigger costs to it all, just the biosecurity.
Yeah,
ensuring regular safe place. And yeah. Is that okay?
Yeah,
yeah, no, that's great. Thank you. So there are a couple of questions relating to recruitment of curlews to back to where they were born, I guess. And so Phil says distinctions are made between upland and lowland curlew populations. What is the evidence for the transfer of young birds between these two populations, i.e., do or could upland fledglings become lowland breeders and vice versa? I think, Geoff, you're probably the best person for this.
Yeah, I suppose start by saying it's an artificial distinction. I think in terms of are there sort of local adaptations? Are they sort of somewhat different birds? It's a habitat description, and it stems really as a matter of convenience for people like me. The most of the lowland ones are in some sort of floodplain meadow type thing, where one of the big risks is silage cutting, early mowing. In the uplands, you're tending to be on rough pasture or heather moorland or blanket bog, and the mowing in most cases is not the problem. It's other stuff, particularly predators. So yeah, it's not a real distinction. So I mean, I think is there evidence for transfer? On the whole, there is no, if you're in the Yorkshire Dales, right, which is the picture behind me, the birds that are reared on heather moorland may very well decide when they grow up to be 2 years old to nest on the lowlands because they're only about a mile away. Not many birds in the Severn Vale will switch to the uplands or vice versa because there's a long way to the nearest upland. I think it's simply a geographical question like that. If the question is sort of a little bit about, could you take eggs from upland populations and use them to restore lowland populations, or would there be something funny about them? I think the answer is almost certainly not. they're not so specialized that sort of upland populations have kind of gone their own slight way and they've got some instinctive liking for something different. I mean, I can't prove that and I don't know it for sure, but I'd be incredibly surprised. These birds are pretty adaptable. They rock up in a range of places. They can learn. Essentially, they're a bird that learns rather than is instinctive. Again, that's a generalization, but on the whole, it poodles around when it's a chick and it pulls around when it's a juvenile, and if it doesn't die, it's kind of learned what to do. And so yeah, I don't think you'd be sort of worried about artificially moving them between, if that was the question.
Yeah, that's great. Thank you. So there were a couple of questions about predator control and forestry, and what I will say is they're really interesting questions, but we do have more seminars coming up, one specifically on predator control and one specifically on forestry. They're all on our website events page. I think they're later on in the year, sort of September, October time, but all of those questions will be addressed then. I have one for Amanda, and it's Phil again. He says, thank you, Amanda, and well done on your work. What can you tell us about the choice of release location and the results in terms of curlew returning to breeding sites in Shropshire or elsewhere?
So the release, we're releasing from the pens. The first year we released our 6 from a migratory roost where we knew there would be a lot of other curlew moving through. So we had a very good sense that they would be joining up with other curlews on their passage. From then on, we have found a spot to rear our chicks and release them, and actually our operation is quite close together. So the incubation chalet is relatively close to the pens, and then we release out of the pens, and they are in the Shropshire Hills area. They are on the side of a hill, so they're in grassland, but they've got heathland up behind them. So they've got before we release them, we bring down bilberries. We cut bilberries off the hill, and this is particularly relevant when we've got, say, a dry summer and we're anxious about what they might eat when we release them, just for those first few days. And I can tell you the poo turns purple overnight. It works perfectly. But we're releasing them on grassland with moorland up behind. We're working with the farmers to make sure that they're not cutting around the dates that we want, or any other agricultural activity at the dates that we want to release chicks, because we know that there are going to be chicks out there. Some of them disappear, some of them just hang around for a few days, mainly a maximum of a week. So that's our setup. In terms of our returning birds, we've had 8 in those radiuses that Geoff has talked about. So in 2019, I think we had our first, which was the first time we were likely to have a headstarting chick back. We had a chick return and attempt to breed, but unfortunately it failed because it's in the world. We've had I think we've had 3 or 4 actually what we would consider to be in our landscape, and this year we had another bird that bred, and we actually head-started the eggs from that bird. But as Geoff has said, I think we need a lot more data on where these birds are returning to before we can be sure that this is working in the way that it does with other waders.
Thank you. Right, I'm just flicking through. There are some really great questions. One, and I'm not sure who best to aim this at, but have you had any interaction between adult curlew and juveniles whilst rearing them in the pens?
I can tell you that we have nests all around our pens. Sadly, we desperately try and keep the one that's closest, but there is a local cat that has a say in the fate of that nest, which is very annoying. But we do have birds flying over, and we do have a flutter of and calling, and we have a flutter of little chick calls when that happens, and we hear mimicking of the adult calls as well. So that whilst it's not great interaction, that's as much as we have. I don't know whether any of the other guys have had seen any.
Anything? Or Nige, have you had it with any other species?
With godwits, we have in a captive situation. So whenever we start a project, we want to find out how to do it as best we can. So we tend to start with a captive population. So before Project Godwit started in 2017, in 2016, we brought some godwit eggs from Germany from a captive breeder, and we raised those babies and then kept them for the duration of Project Godwit, so we could kind of be just, learning more and more about their aviculture. And every spring, black-tailed godwits will come and sit on top of the aviary, and they'll call to each other. And we've only released birds, curlews, in 2019, but we do have birds flying over the facility where they were raised regularly. We can't see that if they're our birds, whether they're wearing tags, because it's a flyby. But we never used to have curlews do that before we reared and released in 2019. So I think they do know. They do obviously recognise their own species, so the godwits tell us that. They come and say hello to each other, and the curlews appear to kind of come and have a look at where maybe where they were hatched and raised. We definitely have the cranes. Well, I'm sat in the crane shed office at the minute. We have the cranes regularly that were raised here fly over, and they actually look down at the site. You can see them twist their head and have a look. So I think I'm not so much talking about interaction with the other birds, but they definitely seem to interact with the immediate environment that they were raised in. Certainly the cranes do, and perhaps the curlews are as well. We just haven't seen the tags. But a couple of hundred meters that way to the east, we've been throughout the winter. I think Mike Smart's in this forum. He's been regularly seeing head-started birds in the fields around us. Probably less to do with the rearing site and more to do with the fact that it's a ridge and furrow field that's very wet in places, and they like to go there to eat what they can find.
That's really interesting. I'm just going to do maybe one, potentially two more, because we've run over quite a lot. Sorry about that, everyone. Tim would like to know, and this is quite a complicated question, how much does a head-started curlew cost? If anyone wants to take a stab at that one.
It's a really good question. I think Nige might be the best person to answer. Can I just very quickly say, I think that's a very good question, and in a sense, it's something I've been sort of driving at for a while now. Is we have a few of these weapons in our armory, okay, nest fencing, predation control, head starting, and I think what we kind of want to do, what we need to do, but we haven't really done it yet, is to end up where we put them all into the same currency, which is fledglings per pound, and you achieve your goal in different ways, by predator control, by putting up fences, and some of them are kind of a nest fence, for example, will increase your nest success. It won't affect your chick survival, and it's not a massive increase in nest success. It helps, but it's pretty cheap. Head starting is pretty expensive, but it's a huge increase. So what we need to do is bring those things together and say, right, what's the equation look like for those three? And of course, it will be different in different places and different times. But I don't actually. What is the answer to the question? Nigel or Mandy probably certainly know better than me.
I would have a quick stab. Geoff and I were in a meeting yesterday with RSPB talking about an extension for Project Godwit, which is an EU-funded life project, and we'd like to maybe look at continuing it, funded by our respective organisations for a couple more years. And just a very quick calculation came up with £60,000 for maybe 30 to 80 Godwit chicks. Now, the biggest cost there is the hire of a porter cabin. Pay a porter cabin 10 grand a year for a 4-month hire. And then we rent accommodation for the staff to live in. So we've got established staff members who are based at Slimbridge, who obviously take a salary for the 3 or 4 months. And then we hire a couple of other assistants for the duration of any of our field projects. So normally it takes about 4 people between 3 and 4 months. So let's call it like 1 annual salary. And then either the accommodation and the hire of a rearing facility if you haven't got one on site. And as I said, it was about 60 grand for between 30 and 80 godwits. When I say 30 to 80, it all depends on the phenology of lay. If there's flooding and we have to rescue eggs later in the season, then we might do up to 80 chicks. At present, we do somewhere between 30 to 40. I don't know if you can help with another answer, Amanda.
Well, I just got out the calculator and the spreadsheet when I saw the question, and it's something that I think it's really hard to pin down. because as I've said before, in an ideal world, we'd be doing all this naturally. So our team would be working on other stuff, and without the team, the basics of our accommodation and our 2 head starters and all the food and the consumables and the equipment that we've had to replace, I'm hoping is going to cost us £741 a bird if we rear the same amount of birds as last year. Now I've got a lot of costs that aren't in there because it's the whole team's time input during that period to that work, and also we've now got the kit, and the kit's really expensive, so obviously you're spreading that fixed cost of the kit over the years. So in the first year it was much higher than that when we were starting with kit. We're talking up in the thousands, and I think those figures are still low because we haven't that's a low figure because we haven't managed put the other stuff in. What I should also say is that in Curlew Country is really lucky with its support. So we have people giving us stables for that first chick stage. We have all those volunteers coming in, all of that stuff, and that it's fantastic and it's altruistic, and without that we wouldn't survive because we just are a very tiny organization with no sort of fundraising power, like to compete with all the sort of major organizations that you could think of. So it's sort of almost need, and I have to say that all of our staff put in a huge amount of voluntary time as well.
Can I just go nap in here and say there's just a couple of things I think we need to underline with a big red pen that's coming out of what everything everyone said. One is it's absolutely imperative that if you're going to do headstarting, you have to get a license. So it's not something you can just go out and do. It's actually illegal to get the eggs without a license, and I think that's lots of information available on that, but it's worth knowing. And the second thing is that and a question I think that would probably worth asking Nigel and Geoff: does headstarting only work if you commit to it for multiple years, like Mandy is doing? But Slimbridge has only done it for 1 year. So what is that sort of commitment?
Well, okay. So to be honest, we have advocated you should only do it for multiple years, and our 2019 trial is us doing exactly what we said you probably shouldn't. I suppose in our defence, to some extent, it was a trial in a place where it was logistically miles more practical for us to do it, and then a little virus came along and various financial issues arose as a result of that. But I guess I mean, does it need to be multi-year? Yeah. In the vast majority of circumstances, you simply won't release enough birds to make enough difference unless you do multi-years. And it comes back, I think, to the more general point of, I would always advocate as much as possible you kind of have a plan of what is the population I'm trying to help here. What's my geographical scope? What's it doing? How big is it? And what's its trend? How much of a difference am I trying to make? And then you go back to saying, okay, how many birds do I need to head start over what time to make that sort of a difference that I aspire to? You've got to kind of see if the equations sort of, equations, it's just a few sums, but do the sums add up to make the difference I want to make? And is it realistic? And of course, as I've said, there are actually a few things we still don't know about, and as Mandy's also stressed, about there seems to be a bit of a deficit in birds being alive, but not necessarily breeding where we thought they would. So there's a few unknowns anyway. But I guess yes, broadly speaking, yeah, you kind of need to. I would be very nervous about starting without thinking, without having a longer term plan. But again, I hesitate because I don't want to come across as sound like, I work for this reasonably well resourced big conservation organization. Everybody don't do it unless you're sitting on a great big pot of money and you can do it for 5 years, because Mandy and co have not had that security of tenure, shall we say, with their project, and they have kept it going and they've done an amazing job. And conservationists do not all need to look like us at WWT or RSPB. So I'm trying. I guess I'm very reluctant to sound snooty and no one must do it unless they've got 5 years of funding. But at the same time, yes, you kind of want a long-term plan. Yeah.
Thanks, Geoff.
I think that was most of the questions. There are various comments saying thank you so much to the speakers, and that the presentations were really illuminating and educational, which I also agree with. They were fantastic. I think we've got most of them. There was one more from Annie, if we answer this really quickly. Do you think there's a place for headstarting in the uplands, even though the population is bigger?
I've typed to reply.
Ah, right, sorry about that, I missed that. In which case, I think we've probably got it all. So I'll hand over to Mary. Thank you.
So thank you, everybody. I mean, really, thank you, Amanda, Geoff, and Nigel. It was just so interesting, and some real sort of the science, but also the emotional side of it as well, and the practical side of it as well. So thank you for that. Our next one is on the importance of curlews in culture and getting the people really engaged in conservation and wildlife again. That will be our next one, and that will be a really beautiful seminar, I hope. So thank you again. Please remember to fill out our little survey. Please, if you've got any pennies in your pocket, support Curlew Action with a link in the chat. And thank you to our speakers, and thank you to you for joining us. Thanks. Bye-bye.
Thank you.
Thank you.
Thank you.